Hello viewers, in today's class we are going to discuss a very nice integral, right? So in this lecture we'll see how we can solve this integral by making use of the concept of the properties of beta and gamma functions, right? So let us start. So let us call this integral as I, right? Now see, here we have the integral 0 to 1 and the integrand is 1 minus 1 over x raised to 1 over 3. So here we'll see how we can convert this integral into a beta function, and then subsequently we can apply the properties of beta function and the relation between beta and gamma functions and other properties, right? So let us rewrite this integral as 0 to 1, and here we can write 1 minus 1 over x as x minus 1 over x raised to 1 over 3, right? So now let us again simplify it. So we can write it as x minus 1 raised to 1 over 3, and here we have 1 over 3. So distributing this exponent over x minus 1 and x. Now we can write it as 0 to 1, and taking x raised to 1 over 3 to the numerator. So we have minus 1 over 3, and here we have x minus 1 raised to 1 over 3 dx. Now let us write this integral like this: 0 to 1 x raised to minus 1 over 3, and let us take minus 1 common from x minus 1, right? So what we will do here, we'll write x minus 1 as minus 1, and here we can write 1 minus x, right? So here we have minus 1, and then we have 1 minus x, and we can write the exponent 1 over 3. So now we can distribute 1 over 3 over minus 1 and 1 minus x. So we can now write minus 1 raised to 1 over 3 outside the integral, and here we have 0 to 1 x raised to minus 1 over 3 and 1 minus x raised to 1 over 3 dx, right? So here we have taken minus 1 common from x minus 1 in order to convert this integral into a beta function. So now here minus 1 raised to 1 over 3 is equal to minus 1, right? So we can now write minus, then we have 0 to 1, and here we have x raised to minus 1 over 3. So minus 1 over 3 can be written as 2 over 3 minus 1, expressing minus 1 over 3 as 2 over 3 minus 1, and here we have 1 minus x raised to 1 over 3, which can be written as 4 by 3 minus 1, and here we have dx. So now let us apply the definition of beta function. So the beta function is defined as beta m comma n as the integral 0 to 1, and here we have x raised to m minus 1, and here we have 1 minus x raised to n minus 1 dx. So this is the definition of beta function, right, where m and n are greater than 0. So now if we compare this integral with this one, then the value of m is 2 over 3, right, and the value of n is equal to 4 over 3. So now this integral I can be written as a negative, here we have minus sign, and beta of m comma n, because this entire integral is now beta m comma n. M is 2 over 3, n is 4 over 3, right? So now we need to find out the value of this beta function, that is beta of 2 by 3 comma 4 by 3. For this we'll express the beta function in terms of gamma function. So now we know the relation between beta function and gamma function as beta m comma n is equal to gamma n multiplied by gamma n divided by gamma of m plus n, right? So here beta 2 by 3 comma 4 over 3 is given by gamma of 2 by 3. Then we have gamma of 4 by 3 divided by gamma of 2 by 3 plus 4 by 3. So now here we have gamma of 4 by 3, right? And here we have gamma of 2 by 3. Now see here gamma of 4 by 3 can be written as gamma of 1 plus 1 over 3, right? So gamma of 1 plus 1 over 3 can be written as 1 over 3 gamma of 1 over 3, right? So we have written this value of gamma of 4 by 3 like this by using this relation, that is gamma of 1 plus n is equal to n times gamma of n, right? So n is 1 over 3. So 1 plus 1 over 3 is 1 over 3 gamma of 1 over 3, right? And moreover here we have gamma of 2 by 3 plus 4 by 3, which is 2 plus 4 6 over 3, that is gamma of 2, right? And gamma of 2 is equal to 1 factorial, right? And 1 factorial is equal to 1. So here we have used this result, that is gamma of n plus 1 is given by n factorial, right? Okay, so now this expression, it reads like this: gamma of 2 by 3 and gamma of 4 by 3 is 1 over 3, then gamma of 1 over 3, and in the denominator we have 1, right? So this is now it can be written as 1 over 3, then gamma of 1 over 3 and gamma of 2 over 3, right? Okay, now see, we can write this expression as gamma of 1 over 3, and here we have gamma of 2 by 3, which can be written as 1 minus 1 over 3, because 3 ones are 3, 3 minus 1 is 2. So gamma 2 over 3 is 1 minus 1 over 3. So now here again we'll use one important relation from gamma function. So now using the Euler's reflection formula, which says that gamma of n times gamma of 1 minus n is equal to pi divided by sine n pi, right? So now see, here we have gamma of 1 over 3, gamma of 1 minus 1 over 3. So the value of n is 1 over 3, right? So this is gamma n times gamma of 1 minus n, right? N is 1 over 3. So the value of this expression can now be written as pi over sine n pi, right? So we have sine n. N is 1 over 3. So this is pi over 3, right? So this is 1 over 3 pi divided by sine pi by 3. So sine pi by 3 is sine 60 degrees. That is equal to root 3 over 2, right? Now taking 2 to the numerator, we have the value of this expression is equal to 2 pi over 3 times square root of 3. So now our integral I was negative of beta of 2 by 3 comma 4 by 3, and the value of this expression is 2 pi over 3 root 3. So here we have 2 pi over 3 times square root of 3. So viewers, the value of this integral is equal to minus 2 pi divided by 3 times square root of 3.